Great. Thank you, Ashley, and welcome everybody. Thank you for taking time out of your day to participate in this event. Again, my name's Tad Whitchurch, and I'm in Northern Illinois. And with me is my colleague, Gary, to help with the questions or any chat or any issues that you might have. Today's presentation is on the Fusion 360 product. I don't know if you're familiar with it or not, so I did want to run a couple quick polls, so just heads up, and if you could give me a couple mouse clicks, I would appreciate it. The first poll is just quickly, what is your primary design tool? I'd like you to go ahead and answer that for us if you don't mind. It won't take long. Give it about 10 seconds or so. And hopefully the poll's working. Do you see it on your screen, Ashley? Oh, there it goes. Here we go. Here we go. Thank you, everybody. Thank you, thank you, thank you. All right, we'll give that about 5 more seconds. And it's primarily AutoCAD, Inventor, somewhat of a split there. So I thank you for that. One other quick one here, if you don't mind. Do you have in place any sort of document management system? Again, just a mouse click on that and we would appreciate it. We'll give that about another 10 seconds or so. I did notice that there's a lot of AutoCAD people in attendance and Inventor people in attendance. All right, thank you, everybody. Now, today's presentation, again, what I'm going to do is I'm going to focus on the Fusion product, and we're going to look at this as a high level, okay? We don't have enough time to get into the picks and clicks of how to design something or how to put together an assembly or how to machine a part. So this is a high level overview, not nuts and bolts at this point, and we're going to tour the Fusion interface, give you a look at that, and also define and show you what they mean by Fusion WorkSpaces. And then I'm also going to show you the learning panel, just in case you start working with the software and you want to get some quick online help, some resources there. And I will give a kudos to Autodesk here. They have really beefed up their help system and their blogs and so forth. So I think they've done a really nice job there. So the first 3 items listed there, we're going to do somewhat together. I don't want to really jump back and forth between PowerPoint and product and back and forth. So we're going to knock out the first 3 items together, and then we'll finish that up, and then we'll get into more of the team site. And big question is always, how do I get my Inventor files to Fusion, or how do I get my Fusion files to my computer, that sort of thing. We'll go through that also. So enough of that. On your screen, hopefully, is the Fusion interface. You'll see that I'm really in a web browser. If I minimize this and maximize it, it's pretty much a web browser, and we are connected through the internet to the Fusion product running on the cloud. So that's a big differentiator there between AutoCAD and Inventor, is that this is all cloud-based. Now, from a user standpoint, for the Inventor people, and probably a little bit for the AutoCAD people also, the interface is really friendly and familiar. You have at the top your typical ribbon, and you can move in between the different ribbons. Fusion does have sheet metal. And point, I can also mention that as of right now, they do not have weldments. So of course we can put together tools, assemblies, build and create parts. And you'll notice on the ribbon, you know, we have inspect, insert, selection over on the right. And as you go through these ribbons, the inspect, insert, and selection are consistent. It looks like construct is also. Okay, there's drop downs available to you underneath each ribbon. And also your right mouse button is in play here. Depending on where you are, the right mouse button is sensitive to where you are in the design. The browser on the left is familiar with people who are using Inventor now. These can be opened and expanded. You'll notice that underneath this particular piece part here, for example, as we highlight it, we have the origin, the bodies, and there's a decal on there also. When you look at the bodies, there's not really a nice history tree here like you might expect, but I can turn it on and off quickly just by hitting the light bulb or the eye next to it. But what you might be looking for is down at the bottom of the screen. Here's the history assembly that we put together. And just like an Inventor, rewind this and hit play and kind of go through how this part was put together. So yes, within Fusion, it does maintain the history of the design as built, and you can, of course, edit any of those features at any time, just like you would expect, and very much, again, familiar, similar to Inventor. We can roll back to certain areas from within the design by simply dragging that back. And we can also open it up. So I believe if you're using CAD now, AutoCAD or something else, Inventor, the interface should be fairly friendly to you. And I think you'll be able to get familiar with it rather painlessly. On the right, you'll see my name, upper right, that's me. But underneath here is where you'll find your account information from Autodesk. And you'll also have a way to work with different teams. And this is where you get into things like, you may have heard of BIM 360 and Fusion 360. It does include with it a team site. And what that really is somewhat of a cloud repository for you to store your data, right? Because we are working in the cloud. So all of the components of this knife, all the different piece parts are stored in the cloud. So the team site is a repository there for you to see different versions, share data with your colleagues or contractors and so forth. You, as an individual, can only have one team site, but you can belong to several different team sites. You can be members of different team sites. We have an Autodesk CAM team site. My colleague Bond has a team site, as does Gary. And then we have our own little internal Hagerman team site. There's also the help here. I wanted to mention the learning panel. The learning panel flies out from the right, and we're in the design environment right now. So you can see here all kinds of different learning tips, quick tips, help along the way. And as you work with the software, for example, if I were to move over to manufacturing, the learning panel changes to manufacturing tools. Go back to, let's go to render perhaps, and you'll see here how the learning panel changes to render, and I can go back to design, and you'll see how it moves the learning panel back into that environment. Sketching is very much similar to what you may be familiar with. If I were to create a sketch, for example, and just put it perhaps on the XY plane, you'll see that the panel here opens up for you, and you have all of your tools that you're familiar with: line, arc, circle, you know, points, texts, rectangles, patterns, all the good stuff that you should be familiar with, including, you know, fillet, trim, extend, offset. All of your constraint tools are here. and we'll go ahead and finish that sketch. I didn't do anything, okay, but it did add it to the browser, I guess, or the feature tree, the history tree down here is that new sketch that I built. This is all mouse sensitive also, so I can right mouse click on that and just delete that sketch. I could go to a new blade or a chamfer, and I could right mouse click on that, edit that feature, and it would pull up the dialog and allow me to make changes to that. So from a design standpoint, it's pretty much familiar with Inventor. We have had people, Inventor users, jump right into Fusion. But don't worry if you need help. We also run training classes on Fusion. Now, the key to this presentation is that Fusion is more than design, okay? And the workspaces are where you switch between the different environments. And you'll find the workspace up here in the upper left. It says nicely change workspace. So you click on that, and here are the different workspaces that are available to you. And we're going to go through these one by one. The simulation workspace, we're going to have about maybe 50 seconds of dead silence there. So we might do a quick check on everybody and make sure everybody's getting okay. And we are cloud-based, so 50 seconds could turn into 40 seconds or 60 seconds. But we'll start with the generative design environment, and this is a big push here for Autodesk, really high on it. What it does, what the generative design environment does for you is it allows you to ask the software to do a lot of the work for you from the design standpoint. For example, if we need to connect these three different cylinders together with some sort of a bracket, we could use the generative design and fill in a few blanks on the study, define what it is that's important to us, what are the conditions of it, is there any load that's going to be put on this thing, is there some criteria that you're interested in trying to maintain. An example of something like that might be that this particular piece part, while it can be all fancy and curvy and everything, from a production standpoint, I would really like for the milling to primarily be 2.5 axis, but go ahead and show me if it goes out to 5 axis what those designs are. And then you can generate the results, and the software then processes this in the cloud. And this might be a new terminology for you, is something called cloud credits. Those are items that need to be purchased, okay? A cloud credit, one credit is typically not enough for some of this stuff, that most of them ask for 2 or 3 credits, and I think they can be purchased in packages of 10, but our sales reps could help us a little bit with that. So when you pull the trigger on the software and tell it to do its thing, it goes into the cloud and processes and puts all of this information together. What your criteria was, you wanted to maintain a certain material type, you wanted to do 2.5 axis machining, and we can go now and look at the results of that and see here that 2.5 axis cutting, it came back with 6 different results. If we get into more of the 3 axis milling, we're getting into some curved shapes. But let's go ahead and just take a look at this guy here. And you can see that this is what the generative design software together to connect those piece parts. We could then save this file, machine it, put it into our assembly, and be ready to go. A lot more time could be spent on generative machining, that of which we don't really have time for today. But it is a really nice function that does come with your Fusion software. Rendering now is exactly what you would expect it to be. It does render, and this is also cloud-based and requires cloud credits. So when you do a render, the materials and lights and so forth that you apply are then sent to the cloud. Your credits are applied to the cloud. It does the rendering in the cloud, freeing you up to continue designing or working. And then when it's done, it returns those results from the cloud to you. And in this particular case, and again, for the sake of time, here are several results of rendering that was submitted and returned from the cloud. You can take a look at any of these at any time. And they do stay with the part, okay? So if you do go through the cloud and you ask it to do rendering or generative machining or simulation or anything like that, the results come back to you and stay with you. So you don't have to use cloud credits or go ask the software to re-render to see those results. For example, in this case, for the sake of time, the rendering was done before our event, and then I was just able to pull them up and show them to you. So you can go through the different options, find ones that you might like. You can also download any rendered image, control how it is being rendered. Is it for a website? Are you interested in printing it? Here's an example of the cloud credits. Whoops, sorry about that. You know, if we wanted to print something out in a certain resolution, the software is informing us that that's going to take about 20 minutes, and you need three cloud credits are required to perform that for you. So again, it's not really that terribly expensive. So again, we have the design tools, generative design, rendering. It also does animation. Animation is pretty straightforward, where we have our storyboard down here at the bottom, and perhaps let me just put something together here quickly for you. We'll start down here at perhaps 1 second. Let me delete this. So we're at 0 time. If I slide this out to about 2 seconds, and then we can replay that. Okay. We could also tweak different components. So we'll slide this out here maybe to 4 seconds. And I'll grab this puppy right here. I'm going to transform it up in space. I might slide it out a little bit more. I want to take this component right here, and we're going to go ahead and just turn that off. And I'll slide it out here more. I'm going to grab the blade and the blade holder. And then we'll just rewind everything. And let's see what we got. And I'm no animator, but I can make them now. So Fusion's very simple as far as creating some of this, and the user interface really in general. I do want to show you the simulation side of it also. And I might close this down, and maybe that'll help us a little bit. But it does have simulation functionality, much like you would find in Inventor for stress and so forth. But with the Fusion, it does also include heat. Okay, so a little bit of that interface, and this is another example where the simulation and the number crunching took place on the cloud using cloud credits, and the results of that definition were then returned back to me, the user. And hopefully in just a few more seconds here, we'll go ahead and see those results. So basically what we have is a compartment, much like the old desktop computers, where we have a fan blade and we have some electronics inside of it. And we're curious to know what the heat does inside this box and if our fan is in fact doing the job. So the results as they come in, we can view the results in different ways. We have a slider bar on the right where we have color coding. We can also, come up here. What's this hot stuff? You can see then it's this guy right here that's heating up. It's over the temperature that we've told it we need to maintain, and it's giving us the actual temperature of that component. Different methods here. You can kind of see how things cool. Obviously, things with the fan up front, they cool a little quicker than the objects in the back. But this guy right here is staying too hot. Is that okay? Or do we need to make some design changes? You can cut section planes through your simulation. Get up off the top of there. There's heat on top of that also that is impacting the space. You can even turn this plane if you'd like to define, a different section view. Go through the part. See that, yes, it is that guy that's heating up. Come out here beyond it. What's happening out of the side of it? Not too bad. So again, focusing on the workspaces from within the Fusion product, we have design, obviously generative design. You can do rendering here, cloud-based animation. You can do right within your environment. Simulation, on the other hand, is also more cloud-based. I guess maybe that's not the right word, but you send your simulations and you send your rendering and you send your generative designs to the Autodesk cloud utilizing your cloud credits. Drawings, we're probably not going to get into much for this time, but like Inventor or Model Space in AutoCAD, the drawing creations from within Fusion, Inventor, and those tools are somewhat of a gimme, right? Because if you put the time and effort into creating a 3D design, the drawings can be created, and we'll see with time towards the end here. What I'm going to do is get into a little bit here of the manufacturing side of the product. Manufacturing is a lot like you may have heard before Inventor HSM. HSM stands for high-speed machining. And they've renamed that, they've rebranded that, Autodesk has now, to Inventor CAM. So that same functionality on your desktop is available within the Fusion cloud solution. What we'll do is we'll maybe grab this piece part here. I'm going to ask the software to go ahead and find that for me in the browser. Here it is. We'll right click on this and we'll isolate that. And we'll go ahead and apply some tool path to this. We're going to switch to the manufacturing environment. Our ribbon changes, and for the most part, it's just working left to right. So I'm going to go ahead and define a setup. The software is putting stock around this setup for me. I do want to go and define the model orientation. I want to select the Z-axis, so I'm going to pick this little face right here so that it orientates the Z-axis up for me. That would be our tool vector. X and Y, I'm not really too concerned about, at least for what we're doing right now. But I will go ahead and define a stock box point for where is 0, 0. We'll pick this corner, and you'll see now that if we machine this, our G code will have positive X values and positive Y values. If you prefer to have your touch off in this corner, then your G code will have negative X and negative Y values. So this is really dependent on how you're going to set this part on a machine and have it manufactured. From here, and I'm not going to machine the whole thing again for the sake of time, but we'll show you the interface. I'm going to go ahead and do some adaptive clearing. Let's grab a tool. The software installs with just a boatload of tools available for you right now to grab. All kinds of different drills are available to you. You also have all kinds of different milling tools, even turning tools are available to you. I'm going to go ahead and maybe grab this 1/2 inch flat. Again, using the machining panel here, we're going to just move from left to right. The geometry's already been defined. It's the boundary of the stock. Retract planes, where's the bottom, where's the top, what's your retract level are defined here. The passes tab is generally where you define what is happening in material. And then the linking tab is where you will go find what is happening inside of the material. For example, ramping in, ramping out, retracting, and so forth. So we'll go ahead, just leave some stock on here. I didn't really change anything other than picking a tool. We'll go ahead and click OK. The software will do its thing quickly. And really, in just a matter of a few seconds, we can rough this part out with the tool that we selected. You control the step downs, you control the speeds and feeds, you can even control the entry and the passes tab. I'm going to go ahead and just real quickly, maybe one more. I'll duplicate that operation. That was a pretty big tool, wasn't it? We'll go ahead and edit this one. And let's grab a different tool. And maybe I don't see what I want here. It goes down to 3/16. I prefer an 1/8. I see an 1/8 ball. So why don't we just go ahead and define a new tool. I'd like it to be a flat end mill. I'd like to work in inches. Let's go ahead and make that a 1/8 inch diameter. A little worried about the flute length, so let's bump this up a little bit here. We'll go 1, that looks good. Shoulder we'll make 3/4. That gives me the ability to maybe give it a little bit different flute length. And as you make all the changes, the graphics on the right update, which is sweet. So we'll go ahead and use this tool. You can define your speeds and feeds here also, or you can define them while you're applying it to a specific operation. You can define your holders also, define them manually yourself, or go ahead and select different holders that were installed and ready to go for you. So let's grab this tool, basically the same operation. We just duplicated that operation. But I do want to jump over here and tell the software to do rest machining from the previous operation. That way we're not machining this outside area again. And pull the trigger on that. I got a little bit of the outside. Just like in design and manufacturing, to make changes of any sort, it's really nothing more than editing the operation with a double pick or the mouse, and I might go and tell it the machine boundary is actually the silhouette of the part, and go ahead and recalculate that for me. Excuse me. There we go. Now we're not machining around the part. What do we have? Let's take a look. Rather than watching that rougher simulate the whole thing, I can just hit this button here and it will clean out all that material from the previous tool so that I can focus now on this new operation that I just created. I could probably change the helican. And I could probably change the step up, the minimum step up. But it does a very nice job there cleaning that out. We could very well be ready to come in with a ball nose end mill and work with that on this particular setup. Again, just kind of keeping an eye on time here. That is basically the different workspaces that we've gone through, design, where you build and assemble things. Generative design, again, is where you can take operations or design criteria, design conditions, material definitions, and so forth, and send that to the cloud for it to determine different possible design that may fit the bill for you. Rendering, obviously, it does exactly that. Kind of a crazy one here, but don't know if you do rendering out on the garden. Animation, we talked a little bit about that, and I was able to show you that. Simulation, again, pretty elaborate, very nice job. The new study box comes up for you. So again, Autodesk doing a wonderful job of guiding users, where you can simply define new studies, whether it's stress or frequency, thermal, nonlinear is there. Check about buckling or any shape optimization. And then finally, manufacturing that we just looked at. Now, to step back here a little bit, and what we'll do, get this guy back up on the screen. Just to quickly tell you where we're going here, we've knocked out 3 of these items pretty much. Let's now move towards the team sites, how to get files from the cloud and back, and what is the interrelationship between Fusion and Inventor. We have Fusion files, we have Inventor part files, we have Inventor assembly files, and so forth. So let's take a quick look at that from scratch. So again, just a reminder here, I am in a team site that's just called CAD's data. Nothing fancy there, you can name it anything you want, as you want. Over on the upper left here is where you typically find your file, you know, file open, file save, file export, undo, all that good stuff. But this panel right here is the panel that opens up and shows us CAD's data team site and the files that are in that team site. Here's my recent data, a default project. Those are all made for you when you fire it up. And then I created one called Webinar February 27th. Below that are libraries and samples. These are all there for you when you're working within the Fusion environment. So to give you a little bit of a look at this, if I were to switch team sites and maybe go to the Hagerman excuse me, team site, Notice that the part that was open goes away because it doesn't belong to this site. And we are in a team location, different folders, different projects, and so forth. So these are repositories for you, again, cloud-based repositories. We'll go to the Hagerman site here. We use this internally for sharing data within the Hagerman SE team. Again, we're scattered throughout the country, but we're really as close as a mouse click away from each other. I'll go back over to my team site. And I know that this might be a little bit confusing here, but let me do this. I'm in TAD's data team. Let me show it to you from a Windows environment. I am now in Windows Explorer. And on my computer, there is a folder that was created called Fusion 360. And underneath the folder Fusion 360 are the different team sites that we called, including TAD's data. All right, we have assets, we have default project, and we have webinar February 27. We look in here. From within the Fusion interface, we see old versions, utility knife, and an ABI. And if we look at that from within the Windows Explorer, we also see old versions, Hagerman knife, and an ABI. This communication between the cloud and your computer's Windows environment is very nice and very useful. And it's actually triggered by a tool called the Autodesk Desktop Connector. So maybe make a note of that, as it may require a separate download. The Autodesk Desktop Connector puts within your Windows interface the Fusion folder structure. So I'm on my computer looking at this like I normally would, a Windows guy forever. I would think that that file resides on my computer, but it doesn't. We're actually looking up into the cloud. Now, this is really helpful because you can simply drag and drop items from your Windows hard drive, perhaps your Inventor project. You could actually drag and drop files into this folder, and then from within Fusion, they will appear and you can use them. So this is really, the desktop connector is really the key for moving files from the cloud and back. It's not the only way to do it, but it is a very nice way to do it. From within Fusion, we can do a file open, and I can open up files from my computer. I could click that and it will pull up, take me to my team site, but I don't have to go there. I could go into any particular file location and pick any part and upload that from the computer hard drive into my Fusion environment. Also, these team sites, this is the environment from within the Fusion interface. This is the environment utilizing the desktop connector, but there's one more. If I click on this item here within Fusion, and I hope I'm not confusing you, it then launches a web browser and takes me to the Fusion team site where I can see the items here also. And here is where we could go and we could archive, we could transfer data, we could even take and open up that utility knife perhaps and share it with other colleagues or contractors so that they also can access the data from the cloud. And it even goes one step further and does maintain versions. And I could download or export from the cloud that design to my computer hard drive, Fusion design. Okay, So confusing as all get out. We have the web browser interface of the Fusion team site. Utilizing Fusion alone, we have the data panel, which shows you also the information on the cloud in your team site. And then we have the desktop connector, which shows you that same information from within Windows Explorer. So how does all this stuff work together? Well, the software does include, this is kind of cool, I guess. It does have tools available and add-ins, and I'm just going to use one of these right now called a Spur Gear. I will point out real quickly that these add-ins are generally created by individuals, not Hagerman. So they would be your resource for support or questions. But let's go ahead and do this Spur Gear. And really my objective here, excuse me, is to get a new design on the screen quickly. I am in Untitled, so I'm going to go ahead and save this file. And it wants to know the name of the file. So we'll call it CAD's Gear. Notice it's going into that folder location. So if we go look at this and look into that folder, you will now see CAD's Gear. If we go to the team site using the browser, I'm in that folder, refresh that. We now see CAD's Gear. It's in use right now. And if we utilize the desktop connector and look at it from a Windows Explorer environment, I'll refresh the screen. There's CAD's Gear. All right, so that kind of shows you that you can access your information and see your information and manage your information in 3 different methods. Put CAD's Gear on the cloud. I have Inventor running here. Inventor's installed on my computer, obviously, typically using projects, maybe Vault that resides on a server or something. So I'm going to go ahead and use Inventor, and we're going to open up. And here, because of Desktop Connector, I am able to navigate to my C drive, the Fusion site. Users CAD Witcher. My team site into that folder. Not seeing anything. Oh, there it is. Yeah. CAD's Gear. So if I click on this and hit open, this launches what you may be familiar with is the AnyCAD functionality within Inventor. And this is where we go and what I wanted to show you in the discussion about moving data between Inventor and Fusion. I need to point out that Fusion uses a completely different file format, okay? So we're going to go ahead and convert this model. Yes, you could reference it, and we'll bring this file into Inventor. And there you go. All right, so we're in Inventor, and notice here there's a cloud in the browser. This is a cloud file. There's no history of the features used to create this file. Okay, I hate to use the word dumb, but that's what we use internally here. It's a bit of a dumb south. It's there for you. You can still work with it, right? So I could go ahead and let's open up that gear because it brought me into an assembly environment. I could sketch on this page. Perhaps I'll just put a big circle in here, something visual for us to see. And now I'm going to save this. When I hit the save button, it saved that file. There is our jet and our extrusion from within this code here with multiple teeth. Let's go and look at desktop connector. You'll see now that here is the Fusion design that was created in Fusion, downloaded and brought into the Inventor environment. And when I work with it in Inventor, as soon as I hit save, it actually created an IPT file. Okay, these two files are not linked. All right, so let's go and look at our team site. Wrong button, sorry. Refresh this. We now have an Inventor part file, the IPT that is sitting here. And if I go to Fusion itself, there is that gear with the Inventor part file. So this is TAD's gear created in Fusion using a Fusion file format. Let's open up this. I'm going to double click on the IPT. Down in the lower right, see what's going on, updating, and there it is. And again, you won't find, there's the solid, here's the browser, that feature isn't there. So the point is, just for clarity, is that the Fusion file format is a different file format than Inventor or AutoCAD. However, you can still work in Fusion with Inventor data, and in Inventor, you can work with Fusion data, okay? It's just that the histories don't make it well. Also in the cloud site here, this is another nice little tool for viewing, all right? So I'm gonna go ahead and just click on this Inventor IPT file, and it takes me to another page that gives me a little more data about it. Is it used in anything or any drawings? Is there any related data attached to it? If I click on the image, you can use the Fusion team site, also BIM 360 if you've heard of that, as a viewer. Okay, so I'm not environment now where I can make any changes or anything, but I sure can view this file. I can zoom in, I can zoom out on it. I can turn things on and off. So let me actually back out of this a little bit. And let's do it to this assembly instead. And the reason I did that is I wanted to show you that you can turn on and off components. In fact, the components are listed for you in here, so I could different views. We can look at the different features with, and I can turn on and off features as need be. Rotate them around. You can explode them. Just drag this out and it'll explode that, depending again now on how it was put together in an assembly, because it does look at the constraint environment to determine how to explode. You can print, you can look at the properties, any file properties of it here, do full screen. So the team viewer is also a wonderful tool. Think about that a little bit, that you could use the team site as a repository for your data and share that folder with your contractors or your internal peeps, and they could go in here and view it, spin it around, and look at it in detail. You can control, you know, who has the rights to edit it and who doesn't have the rights. I am going to time flies when you're having fun, doesn't it? It's an enjoyable product to work in. I have a good time with it. At this point, that really does cover everything that I was prepared to show you. I made it within the hour. I was worried about that. So I know Gary's been working in the background, monitoring any questions or chats that might have been taking place. So at this point, I have finished with my presentation. And are there any questions that maybe I can help with or that didn't get answered? Gary, I don't know if you were able to get them all or not.
Yes, we have all the questions answered so far.
Wonderful. Thank you. Thank you so much. All right, if anybody has any other credits, oh great, I'm glad you had that information. Cloud credits are $100 for 100 packs, so about a buck of credit. And you'll see, and again, just as a reminder, while we were over here and we did some of that rendering, I hope you caught it. If not, it'll be on the video recording that you will get tomorrow. I think it only took 3 credits to render something, so. All right. Well, listen, if there aren't any other credits, or I'm sorry, questions, let me take you back out. And I do want to mention to you that we are prepared to train you on the Fusion. We are standing by, ready and able. And we do have a class coming up in April. If you're interested in jumping in, we'd love to have you. We also are very skilled, but also on the architectural side with both the Fusion site and the BIM 360 site. And again, it's probably worth one more mention that the repository, the team site in the cloud will hold any file type. It doesn't have to be Inventor. It doesn't have to be Fusion. You'll see here an AVI file. Internally here, we store AutoCAD DWG files, we store Word documents, we store Excel spreadsheets, video files, screenshots, you name it. If it's a file that you can touch, you can store it up in this cloud site. We do also have document management solutions. If you're looking at Vault or need some assistance with managing your documents, we are your partner. We have been doing this since day one, have over thousands of clients that we work with Vault, collaboration services and so forth. And we do also have, Hagerman also does have a simulation division within Hagerman and Company. We call them SimSpec, I believe is what they're called, but they're Hagerman Simulation Division. And they can, if you don't have time to learn simulation, if you want to get into some heat studies and so forth, and you don't really want to or have the time to get into the picks and clicks, we provide those services for you. And that group can help you out with that. Really at any time. They also do training. I think we have something they call it 5 for 5. Where basically you get 5 training sessions for $5,000 or something like that. Don't quote me, I'm not a sales guy. But basically from design to manufacturing to drawings to document management to simulation, we're your partner and we'd love to help you. With that, I'll stop talking and I have wrapped up my presentation.
Well, thanks, Tad, for the presentation. If I just want to let people know if they think of additional questions later, you can simply reply to the confirmation or reminder email you receive from GoToWebinar. We can get those to Tad or your sales rep to get those answered. Once again, if you could take a few moments to fill out the short survey, we would appreciate it. It will just automatically pop up as we close down the session today. And again, you'll receive an email tomorrow containing a link for the recording of today's presentation. And with that, I'll say thanks for attending, everybody, and have a great day.